Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another lecture for Computer Science 9618 AS level, and today we are going to start the contents for paper 2, fundamental problem solving and programming skills. The first section we have in paper 2 is section number 9, algorithm design and problem solving. Today we are going to start our discussion on 9.1, that is computational thinking skills. Okay, so what exactly are the computational thinking skills? They are the ability to solve a problem through a number of steps, analyzing a problem logically and producing a solution that can be understood by humans and that can be used by computers. Computational thinking skills involve 5 main concepts or 5 main steps, you can say. The first one is abstraction, the second one is decomposition, then we have data modeling, we have pattern recognition and algorithmic thinking. Okay, so the first thing we have is abstraction. If you have studied O-levels computer science, then you would know what abstraction is. Abstraction means to discard any unnecessary information and only record the key elements or the key information or the absolutely necessary information. So abstraction keeps the key elements required for the solution of the problem and discards any unnecessary details and information that is not required. It is the process of simplifying complex concepts or systems by focusing on the most important aspect only, while unnecessary details are discarded or kept hidden for this stage. The benefits of abstracting the model are development time is reduced, so it can be delivered quickly, because now you don't have to focus on a lot of unnecessary things. You only focus on and develop the absolute necessary things. Program is smaller in size when you don't have to worry about the background color, the animations on buttons and this and that. Then obviously your code would be smaller. It would take up less space in memory or it would require less download time. Greater customer satisfaction as no extraneous features are included. To apply abstraction, identify the purpose or situation of the use of the model or the program that you are about to do. So first of all, you need to identify the main purpose. Next, identify the source of information. Where are you going to get the data required for your model? Is it going to be through direct observation, through user opinion or feedback, or by studying the existing system, etc. Lastly, use the information gathered to decide what piece of information must absolutely be there in the model and which pieces should be discarded. For example, in an ATM machine, the purpose of the ATM machine is to allow a customer to withdraw cash or money from their account. The ability to perform cash transaction is important over here, as that is the purpose of the model, whereas other details can be discarded. Then you would have to check from where the data is coming. So data would be coming from the keypad. The user would be entering their password. The data can also come from the touch screen, that they would like to select different options, as well as another input would be in form of the user's ATM debit card or credit card. These details are important, so must be kept and utilized carefully in the model, whereas other information such as the color of the machine, display graphics on screen, etc. are unnecessary details which can be ignored for now. Next we have decomposition. Decomposition breaks down a complex problem into smaller parts, which can then be subdivided into even smaller parts so that they can be solved easily one after the other. Decomposition leads us to the concept of program modules and using procedures and functions. Because when you break down a problem into subsystems and then further break those subsystems into further subsystems, ultimately you are left with modules that cannot be, or rather should not be, divided any further. Then you can create procedures or functions for each of those modules in order to apply modular programming. So you can solve your problem by creating the functions and procedures according to your decomposition model. Then you can connect those functions and procedures under a same heading or a same tab or same theme, and ultimately once you are done with them, you can connect all of them together and your program would be ready. Any problem that uses a computer system for its solution needs to be decomposed into its component parts. Now, the components parts of any computer system are inputs, the data used by the system that needs to be entered while the system is active, processes, the tasks that need to be performed using the input data, and any other previously stored data, the outputs, the information that needs to be displayed or printed for the user of the system, and finally the storage, the data that needs to be stored in files or on an appropriate medium for use in future. Then we have pattern recognition. Pattern recognition identifies those parts that can be solved in same way. Pattern recognition means to identify, when you are presented with a problem, identify parts of the problem that can be solved in a similar way, so that you can write a reusable program code such as library routines, subroutines, or procedures or functions that can be used repeatedly inside your program in order to solve the problem more quickly. Next we have data modeling. Data modeling involves the analysis and organization of data. For example, here is a structure chart for a website, which is also a decomposed model for a website. There are three modules, as you can see. The first module is the student area, then we have information for visitors, and the third module is contact or contact us. Now inside the first module there are further three subdivisions, or there are further three routines or subroutines, you can say. Then for the second module we have two subroutines, and the third one is self-contained. It does not have any further classification, any further subroutines, or any further subsystems. So inside the student area we have 1.1 events, 1.2 results, 1.3 homework. Now as you can see, all three of them can be run by this thing over here, functions. We can, in any programming language, we can easily create functions for these subsections or subsystems, and then collectively these can be contained in this complete module. Different programmers can work on different modules. This is also known as modular programming, and then ultimately those modules can be connected together and the whole system is a whole system becomes alive. Then in the second module we have about us and faculty information and so on. This is just a sample for a website. It can be about anything. Lastly, we have the algorithm design or the algorithmic thinking. It basically involves developing step-by-step instructions to solve a problem. The algorithmic thinking part basically applies that whenever you encounter a problem, you should think in a logical way and think about what steps you can take to solve the problem, or how you can break it down so that it ultimately gets solved. Overall, this part is totally concerned with how you can write your algorithms, which would be further discussed in section 9.2. So that's it. That's everything you need to know in section 9.1. You have successfully learned everything. What you just need to do is to practice a lot of past papers so you know how to apply this information, especially if you're given a scenario, how you can apply abstraction and decomposition to it. If you can do that, then 9.1 is fairly easy for you. So I hope you have understood everything. If not, feel free to let me know in the comments below. I'll definitely get back to you. Secondly, if you have not subscribed to my channel already, please do so and share it with your friends. Lastly, if you need a hard copy of all these notes along with the topical past papers, the AS study pack, or you need this study pack for computer science, IGCSE or O levels, or you need the study notes for physics, IGCSE or O levels, you can use the form link given in the description below to place your order. I'll see you guys in the next lecture. Take care. Allah Hafiz.